Welcome back. In this lecture video, we are going to see about the regenerative braking of induction motor. So already we seen in the previous class, in electrical braking there are three types are available. One is nothing but rheostatic braking, or it may be called as dynamic braking, and the second one is plugging, and third one is regenerative braking. So as per the previous class discussion, the rheostatic braking and the plugging mechanism. So both method which is used to convert the amount of energy which is available in the brake drum is directly converted into heat energy. So we are not utilizing the energy in these two methods. But in the regenerative braking, the amount of energy in a brake drum that can be converted into useful electrical energy. So that is the main difference between the rheostatic braking and the regenerative braking. So before that, we have to know where we are using this regenerative braking. So the application of regenerative braking, it is mainly used in the electric locomotives. That is nothing but electric trains and elevators, cranes, and some of the hoist. So these are the application where we are using the regenerative braking in real-time applications. So the next one, we should know what is regenerative braking and how it is employed in an induction motor. Okay, so here you may see here this is an induction motor. This is an three-phase induction motor. Normally, a three-phase induction motor which is used to convert the given electrical energy into the mechanical energy. But during the regenerative braking condition, the rotating part of the induction motor, the rotating part of the induction machine is directly coupled with an external engine. This external engine, it may be either petrol engine, diesel engine, gas turbine, hydraulic turbine, steam turbine, whatever it may be. So with the help of some external prime mover, we are increasing the speed greater than the synchronous speed. So the value of synchronous speed is 1500 rpm. Once, with the help of external device, if you are increasing the speed greater than the synchronous speed, so during this condition, the induction motor will act as an induction generator. So that the induction machine, it acts as an induction generator, so it generates the electrical power. So the generator electrical power, it will be returned back to the source. It will be returned back to the three-phase supply main. So before that, we are consuming the electrical power from the grid, from the supply. But after the regenerative braking, we are supplying the power to the power supply, return back. The power supply, it can be returned back. So this is called regenerative braking. So when the regenerative braking is applied, when the actual speed is greater than the synchronous speed. So during that time only, the induction machine, it can act as a motor or generator based on that. So according to the power equation, the input power P is equal to 3 V phase I phase cos pi. Here the pi, it indicates the angle between the stator voltage and the stator current. And the pi, it should be less than 90 degree for motor action, and if it is greater than 90, it will be a generator action. It will be act as a generator. And this is the speed, that is a torque slip characteristics. So here the x-axis, it represents the slip. It represents the slip. That is nothing but with respect to the speed. And the y-axis, it represents the torque in terms of Newton meter. Just you can look here. When when the induction machine is in motor, when the induction machine it acts as a motor, so the torque will be in positive manner. The torque will be in positive. Once the generator is in once it is generative region, the torque it goes to the negative region. It goes to the negative region. So once the induction machine it acts as a motor, the slip value is from 0 to 1. Normally for any machine, the slip value is from 0 to 1. So if it is a motor, it can be vary from 0 to 1, and if it is generator, it can be vary from 0 to minus 1. 0 to minus 1. So it represents the torque slip characteristics of three-phase induction motor during the regenerative braking condition. So what is the advantage? Here we can generate the electrical power, and the generated electrical power can be used for the useful applications. That is one of the advantage. And what is the disadvantage means? For fixed frequency supply, it can be used, but only for a speed above the synchronous speed. That is the main disadvantage of this method. And the assessment for you: in which of the following electrical braking method energy is supplied back to the supply? During the plugging operation, during the dynamic braking, during the regenerative braking, or in all electrical braking types? Okay, now post your answer in the comment section. And these are the few reference paper for this